Hello, myself KVMSharma, a research scholar in educational technology applied to engineering thermodynamics at Vishweshwaraya Technological University. I'm talking on types of thermodynamic system in the mechanical domain in basic thermodynamics course, and the target students are the third semester UG students in mechanical. I am adopting a three-stage approach. The question is, why a three-stage approach? The objective being to understand the thermodynamic systems. Understanding the determinant is very much essential. That's the first stage. The first stage is understanding the thermodynamic interactions, which is the determinant. And the next obvious second stage is how these determinant, namely the interaction, thermodynamic interaction, decides the types of the system. The correlation between these two is a second obvious stage, and the third and the concluding stage being defining different types of systems based on the first and the second stage. I'm not getting into the details of some of the prerequisite, which is very much essential to get into this discussion. Coming to the first step, we have witnessed a number of systems, whether it is an air condition, a car radiator, a power plant. There are certain things getting in, there are certain things getting out. That's what we actually identify as interactions. What is getting in? What's getting in and what's getting out? It depends on how we draw the boundary and what is the system. For example, a power plant, a coal is getting in, exhaust gas is getting out. At some point, a power is also getting out. A car radiator, water is getting in, water is getting out. At the same time, there is some heat energy getting in. So depending upon different systems, we can identify. To consolidate, if we put it in, if we entire thing, if we can categorize, we can broadly categorize as energy and mass. This is exactly what I call as interactions. The entire interactions, any systems, whether it is a human being, an aeroplane, or a refrigerator, can be broadly classified into two interactions: energy interactions and mass interactions. Consolidating from our previous examples, it can be energy can be either thermal, as in the case of thermal power plants. It can be electrical energy, as in the case of a refrigerator. For refrigerator, the energy is the input. There can be a mass interaction as well, a fuel for an aeroplane, a steam in a steam power plant, exhaust, hot air, cool air in case of air conditioning, etc., etc. Now, understanding the first part, the next part is how these interactions, namely mass and energy, is correlated to our basic concept, namely open system, closed system, and isolated system. The simplest way we can understand is through this matrix. What this matrix gives an indication: if in any system there is both mass and energy is interacting, then it must be an open system. Only energy interaction, a closed system. No interaction of either mass or energy, an isolated system. To expand it a bit further, here we have three determinants: mass and work and heat. Work and heat put together represents energy. Energy either in the form of work or heat. This is exactly the same as the concise description given in the this slide. So how we understand the correlation of interactions and the types of the system? An open system, as we understood in the previous slide, there must be both mass and energy interactions. That's true here as well. Only the thing is, the work and heat has been identified, the two critical essential interactions of an open system. Similarly, a closed system. In a closed system, no mass interaction, only energy interaction. Energy interaction in the form of either work or heat. As in an isolated system, neither the mass nor the energy interacts with the system. So, having understood the first and the second step, namely the determinants and their correlation. Let's come to the core objective. What's an open system, what's a closed system, and what's an isolated system? An open system, both mass and energy interacts. Both mass and energy can cross the boundary, the selected boundary. An example could be a cup of hot water, hot coffee. So only the mass in the form of steam is crossing the boundary, and of course heat is crossing the boundary, hence it's a open system. Coming to the next one, a closed system. No mass interaction, only energy interactions. So if we take a piston and cylinder, a typical example, it's totally close to the mass interaction. A heat crosses the boundary, piston moves, thereby there is a work interaction between the system and the surrounding, characterized by the boundary. A boundary is represented by a boundary is something in between the system and the surrounding. Work crosses the boundary, heat crosses the boundary. Both heat and work is a form of energy, hence there is energy interaction and no mass interaction. It's a fluid tight, there is no mass interaction. So this is a fit example for a closed system. Next, what's an isolated system? Isolated system, there is no energy, no mass interaction. A thermos flask being a best example. So whatever the mass inside a cup of hot coffee, mass remains the same and the temperature also remains same, assuming that an insulation is perfect, which is not a case anyhow. Now we need to understand a bit about the concept of the boundary. If we consider any system which is open, this can be transformed into a closed system. If we close the boundary, this is an example. All the three are the same examples with bit of modification. What is the modification? The modification between the first and the second is the closing by a lid. Thereby you are arresting the mass interaction. An open system is being transformed into a closed system, and if you insulate it perfectly and along with the mass, the energy interaction is also arrested. Thereby it has been transformed into an isolated system. An open system, a closed system, and an isolated system. So the concept being pretty simple, it's extremely difficult. We should not be in a hurry to judge a system as an open system, closed system, or isolated system without understanding completely the boundary condition. To summarize, we have understood the concept of the open system, closed system, and isolated system based on a three-stage approach. The first stage being understanding the different types of interactions, that being energy and matter, and energy and mass. In energy, heat and the work being the selected two things. So three energy interactions being recognized in the first stage, namely energy, work, and heat. And in the second stage, we have drawn a correlation, a relation between open system, closed system, and isolated system to the energy interactions, thereby decided which is an open system, which is a closed system, and an isolated system. And an open system wherein both energy and mass crosses the boundary of the system. Only energy crosses the system in a closed system. And an isolated system, neither the energy nor the work or nor the mass crosses the system. Thank you.